Okay, question number 10, we are given this trigonometric equation and we are asked to find the solutions from 0 to 2 pi, giving the answers in terms of pi. Now, with trig equations, what we often try to get to is we want to try and write everything in terms of one trig function. Everything is in terms of either sine, just in terms of cos or tan. And we also can't have two different kinds of angles. We can't have x and 2x. So in this case, we are going to have to somehow use double angle identities to rewrite the cos 2x. So to start with, what we'll do is just write down what cos 2x is equal to. So it could be cos squared minus sine squared. We could write it as 2 cos squared minus 1, or in the form 1 minus 2 sine squared. Right. Now, if we look at the denominator here, where we have 1 plus cos 2x, if I use the second form of this identity, so if I use this form here, I'll get rid of this last one. If I just move this minus 1 to the other side, I'm going to have 1 plus cos 2x. I'm going to have 1 plus cos 2x is equal to 2 cos squared. So I can immediately replace the denominator just by 2 cos squared. So that's what I'll start with. So I'm going to say 2 cos squared, and so let's say 2 cos squared x is equal to, now it might be tempting to write this as sine over cos. I'll not do that just yet. I'll leave this as 1 minus tan x. Now for the numerator, we need to decide what form we pick. Right? It's not always easy to know which one to do. I'm just going to go with the first form here, cos squared minus sine squared, and see what that leads to. So I'm going to say this is cos squared x minus sine squared x. Now for the rest of this question, instead of having to write sine squared cos squared, I'm just going to simplify that to writing c, s, and t for cos, sine, and tan. Right? So what we can do on the left hand side, or in fact, I'll first get rid of this 2 here by just multiplying this whole equation by 2. So the right hand side is going to become 2 minus 4 tan x. So I'm just going to say that's 2 minus 4t. On the left hand side, I'll then be left with cos squared minus sine squared divided by cos squared. Right? Now, what we can do from here is we could split that cos squared into 2 parts. We could write it something like cos squared over cos squared minus sine squared over cos squared. Right? And clearly in this case, what that tells me is I can rewrite this as just 1, and sine squared over cos squared is just going to be tan squared. So this left hand side can then be simplified to 1 minus tan squared is equal to 2 minus 4 tan x. Right. So clearly now we have a quadratic in terms of tan squared. So I'll bring everything to one side and say tan squared minus 4 tan x, and then bring the 1 over to this side. That gives me plus 1. So we have tan squared minus 4 tan squared x minus 4 tan x plus 1. Now, to solve this equation, we are going to have to use the quadratic formula or just plug it into a calculator. Right? Because this is not something that we are going to be able to factorize, so I'm just going to put this into the calculator here. And so if we go polynomial degree 2, and if we substitute 1, 4, and minus 1, sorry, 1 minus 4 and plus 1. Right, and this gives us, so we get 2 plus or minus root 3 in exact form. So we can say that therefore tan x must be equal to 2 plus or minus root 3. Right. So now what we need to do is solve each of these separately. So I'll just split this into 2 parts. So we either have tan x is equal to 2 plus root 3, or tan x is equal to 2 minus root 3. Right. So once again, if you just check this on the calculator, so tan inverse of 2 plus root 3, hopefully we do get an exact form here. So this gives us, okay, so that's good. We get 5 pi over 12 for this. So this is equal to 5 pi over 12. There are other solutions to this, but I just want to solve this bit on the calculator as well. So let's just change this to 2 minus root 3. Okay, so that gives us pi over 12. Now we are asked to find solutions that go from 0 to 2 pi, and if you're solving for tan, solutions occur at every pi radians or every 180 degrees. So all we need to do is just add pi to this. So 5 pi over 12 plus pi is going to give us 17 pi over 12. So that's just adding 12 to this. So the other solution is 17 pi over 12. And 17 pi over 12 is less than 2 pi, because 24 pi over 12 would be 2 pi. Then similarly, adding pi to this one will give us 13 pi over 12. So these are the 4 solutions. So adding pi to this again would go outside the range. So the final solutions we have for this, if I do write them in order, again, you don't necessarily have to write them in order, but the solutions would be pi over 12, 5 pi over 12, then 13 pi over 12, and 17 pi over 12.